If you place a bicone on an inclined track, what do you think will happen? You might think it will just roll down the slope like any other object. However, when we actually put it on the track, something counterintuitive happens. The bicone doesn't roll down the slope. Instead, it seems to defy gravity and climbs up the slope. So why does this bicone appear to defy gravity? In 1687, Newton proposed the law of universal gravitation, stating that any object with mass or energy will be attracted to other objects due to gravity. So on Earth, no matter how massive an object is, it will fall toward the Earth at a rate of 9.8 meters per second squared. In a vacuum, if you drop a ball and a feather at the same time from the same height, they will hit the ground at the same time. But later, Einstein introduced a new idea. He suggested that instead of objects being pushed or pulled together by gravity, what actually happens is that mass distorts spacetime. Imagine a box containing a feather and a hammer. If you move the box, both the feather and the hammer will fall to the bottom of the box at the same time. This shows that gravity isn't a force pulling objects toward one another. What we actually have is spacetime, and mass bends it. Let's use a pencil as an example. If no outside force is acting on the pencil, it won't move through space. It will simply age in place. But if spacetime is curved, as it is near Earth, the pencil will move through space along the curved paths created by the mass of the Earth. This can be thought of as a cone-shaped distortion in spacetime. If spacetime were flat, the pencil wouldn't move. But because the mass of the Earth bends spacetime, the pencil follows a curved path and eventually falls. This doesn't happen because gravity is pulling the pencil down. Instead, it's because the pencil naturally follows the straightest path, which in curved spacetime is a geodesic. Spacetime controls how objects move, and objects control the curvature of spacetime. Now, returning to our counterintuitive bicone, when we let it go, you'll see that although the bicone appears to be moving upwards, its center of mass is actually moving downward. The bicone needs to maintain its motion along a straight line in spacetime, so it rolls forward. As it rolls forward, it seems to climb upward, but what's really happening is that it's following the natural curvature of spacetime.